Hi guys, today we are going to solve quadratic equations. Then I bring here to the class four different types of quadratic equations, or four different forms to represent quadratic equations. Okay, the first one is quadratic equation of the type ax squared equals p, where x and p represents any number. Number two, here of course we have an example. Number two, quadratic equation of the type ax squared plus bx equals 0, and a and b represent any number. And here we have an example. Number three, quadratic equation of the type ax squared plus bx plus c equals to 0, and a, b, and c represent any number. Here we have an example for that case. Case number four, quadratic equation of the type x plus c squared, everything is squared, equals d. Here, c and d represent a constant, any number, okay? And here we have an example. Okay, then let's start with the first case, with the first type. Okay, then 5x squared equals 3. Guys, if we have to solve quadratic equation, we have to isolate x. That's solve an equation. Okay, solve any equation. Then if we are solving linear equation, we have to isolate x, or isolate the variable. In this case, the variable is x, but it's a quadratic equation, then we have to isolate x. Then, if we have to isolate, we have to apply one math principle, that is the property of equality. Property of equality consists in doing both parts of the equations exactly the same. Then we have to divide by 5 and by 5 because we can isolate x with this number 5. Okay, 5 divided by 5 obviously is 1, then here is going to be just x squared, and here 3 over 5. Okay, now the x is not yet isolated because this is square. Then how can we use? We have to use another property, that is the square root property. Square root consists in applying exactly the same in both parts. It's another part of the property of equality, but with square roots. Okay, square root of x squared obviously is going to be x, and here we have to analyze one thing that is interesting, guys. In a moment I'm going to explain. When we apply the property of equality with square roots, we have to analyze two cases: plus and minus square root of 3 over 5. We have to analyze two options: the positive answer and the negative answer. Okay? Why? Let me explain. I'm going to explain here. For example, let's analyze this situation. Square root of 9 is equals to 3. And yes, we always analyze the answer when a square root of 9 is 3. But let me tell you this, guys. When we are solving quadratic equation, we have to analyze another case that is possible here. Okay, the square root of 9 is 3 because 3 squared is 9. That's the reason. 3 times 3 is 9, then the square root of 9 is 3. But it's not the only solution. Okay, we have another option. The other option is negative 3. And let's analyze why. Because the square root of negative 3 is also 9. Then negative 3 times negative 3 is 9. Then, to be honest, the square root of 9 has two possible answers: positive 3 and negative 3. Always in math, until now, we analyze just the positive answer. But when we are solving quadratic equations, we have to analyze both cases. Okay, then keep this explanation in mind to understand that always when we apply the property of equality with the square roots, we have a positive answer and we have a negative answer. Then usually in math, or in this case, in this solution and solving, when we are solving quadratic equation, we have two answers. Not always, but most of the times. Okay, now if we separate, okay, the answer, the square root, then we have that is the square root of 3 over square root of 5. But here we have another situation. In math, we never express a number or an expression with the square roots, at the bottom, in the denominator. Okay, then we have to apply a strategy in math called rationalization. Rationalization is a really simple technique. Okay, really simple. Then, what is it? This rationalization consists in identifying the number at the bottom, the denominator, that in this case is 5, and multiply at the top, the numerator, and also the denominator by that number. Okay? Then this is going to be equals to plus or minus, plus or less, the square root of 3 times 5 is 15, and 5 times 5 is 25. Now, when we separate now the square roots, plus and less, square root of 15 over square root of 25. And now, obviously, you can see that the square root of 15 is not exact, then we can keep the square roots, but the square root of 25 is 5. Okay? Then this is going to be our solution. But let's remember that our solution has two possibilities. This number positive and this number negative. Then when we write here, when I write here plus and less square root of 15 over 5, that means that we have two answers. When x is equals to positive square root of 15 over 5, and when x is equals to negative square root of 15 over 5. Then we have the two solutions there. Okay. Case number 2, or type number 2. Here, 7x squared plus 2x equals to 0. Then in here, when we have this case, we have to solve this quadratic equation. The first thing that we have to apply is the first factoring case, greatest common factor. Because on left, we have a polynomial that we can check the greatest common factor. In this case, the greatest common factor is x, and x times 7x is 7x squared. Now x times 2 is 2x, obviously equals to 0. Then on left, apply greatest common factor. On right, just keep the number 0. Now, when we are in this step, we have to analyze two cases. When each factor is equals to 0, then first factor is x, and x is equals to 0, and the second factor is going to be 7x plus 2 equals to 0. Okay, then one more time. Apply greatest common factor and then make each factor equals to 0. First factor is x equals to 0. We have the first answer here. And the second one is what is inside of the bracket equals to 0. And here we have to isolate x. Okay? Then 7x is going to be equals to negative 2. And then if we apply the principle of equality, or the property of equality, then we have that x is going to be equals to negative 2 over 7. Then we have here answer number 1 and answer number 2. Okay? I told you already, most of the time, usually in quadratic equations, we have two answers. Okay? Obviously, not always. Sometimes we have just one answer, or sometimes it's not possible to solve. Okay? It's not possible to find the x value. Okay? Then, case number 3, or type number 3. 2x squared minus x minus 21. Let me clarify something. When I said this is the name of the type of the quadratic equation, or all of this one, but when I use plus signs here, it's just to represent, but can be plus or can be minus, doesn't matter. It's because it's the name. Exactly the same happening here. Then here we can solve, not always must be plus, can be negative sign. It can be, yes, can be a subtraction too. Okay, the same happen here and happen in any other one. Okay, then let's solve that equation. Let me write this part, this explanation, and let's do it. Okay, then in here we have a trinomial on left. We have to factor. Then if we can identify which factor we can use, which factoring case can we use to factor that polynomial, we can do it. And obviously I know that you know that we can use AC method. Then by AC method, remember 2 times negative 21, A and C, this is equals to negative 42. Okay? And B is negative 1 over here. Negative 1. Okay, this is AC, and B is equals to negative 1. Then we have to find two numbers whose product is negative 42 and whose addition is negative 1. And the numbers are really simple. Negative 7 times 6 is negative 42, and negative 7 plus 6 is negative 1. Then remember, but this factoring case, we have to rewrite the term in the middle. Then, one more time. Let me erase for a moment this in order to provide enough space to continue solving the exercise. Okay, then we have to provide determine the middle. Then the first one is exactly the same, 2x squared. The last one is exactly the same, negative 21. And determine the middle is negative 1. We have to use negative 7x plus 6x. Okay? Then in this process, in this part of the process, we have 4 terms. Then we have to continue solving by grouping. Okay? Then let's continue in here by grouping. By grouping is going to be 2x squared minus 7 in the first parenthesis, and in the second one, 6x minus 21. Okay, for a moment, we have to forget that this is an equation. Therefore, now we are not just writing equals to 0. Okay, now let's continue. Where is common factor for the first parenthesis is x, and here is going to be 2x minus 7. In the second one, exactly the same. Greatest common factor. What is the greatest common factor? Is 3. 3 times 2x is 6x, and 3 times negative 7 is negative 21. Now here we have exactly the same. Then that's going to be the common factor. And what is not common in the second parenthesis? X plus 3. Then this is the factor. Now we have to remember that we are solving an equation, and the equation was equals to 0. And now equals to 0. Then, one more time. On left, we have to factor the polynomial by the method, the corresponding method. In this case, is AC. Okay, but can be any other method. Then, factor the polynomial on left by corresponding case, corresponding factor in case, and obviously equals to 0. Then, guys, remember, in a similar way for this example, for example number 2, we have to analyze, or we have to separate or make each factor equals to 0. Then the first factor is the first parenthesis, x, 2x minus 7 equals to 0. And the second option for the second solution is going to be x plus 3 equals to 0. And then isolate. Then x, 2x is equals to positive 7. Then applying the property of equality, x is going to be equals to 7 over 2. In here, exactly the same. X is going to be equals to negative 2, applying the property of equality, subtraction and subtraction in both sides. Then we have here answer number 1 and answer number 2. As usual, remember we have two possible answers, or two answers for when we are solving quadratic equations. Okay, now let's analyze example number 4. Case number 4 is quadratic equation of the type x plus c equals, x plus c squared equals d. Remember, c and d represent any number. Then here we have that situation. In here, as you can see, the part of the on left is to the square power. Then remember, we have to apply the property of equality with square roots. Then in here we have to apply square root here and square root here. But remember the property with the square roots. When we apply the property of equality for square roots, we have to remember that we have to analyze two possible answers. Plus and minus, when the number is positive and when the number is negative. Now, let's make the operation. Then this is going to be, the square root is going to be cancelled with the exponent 2 with the square, then it's going to be x minus 5 equals square root of 9 is 3. But remember, we are analyzing when 3 is positive and when 3 is negative. I explained why at the beginning of the video. Okay, now let's solve, or let's isolate x. Then x is going to be equals to plus or minus 3, and here in the other part is going to be positive 5. Remember, property of equality, adding 5 on left, adding 5 on right, and this is going to be the result. Okay, now we have two cases. First case, first value for x, when 3 is positive, plus 5, and here we have to analyze when x, when 3 is negative, then x equals negative 3 plus 5. Then, one more time, remember that we say that the square root for 9 is plus and minus 3. Then here I take the first option, when 3 is positive, and here when 3 is negative. Okay, then here, x is going to be equals to, sorry, let me write again. Okay, 3 plus 5 is 8, then we have the first solution, x is equals x equals 8, and here x is equals to negative 3 plus 5. In that case, x is equals to number 2, to 2. Okay? This is the explanation, guys. Remember the 4 cases. Okay? Case number 1, case number 2, case number 3, case number 4. Okay? Each case with a different process or method to isolate or to solve the quadratic equation or isolate x. Okay? Thank you, guys. See you next time.